Howdy everyone, and welcome to ESIN 453. My name is Amarachukwu Nzedibe, and today I have prepared for you a presentation to help you get familiar with ADS. Today I will be showing you how to draw schematics on ADS to simulate their S parameters and manipulate the charts that will be used to plot these S parameters. However, I have not included instructions on how to download ADS and install the student license because the instructions will be included on Canvas. And now we will move on to the demonstrations on ADS. The first step when using ADS is to create a workspace. We can do this by clicking on New Workspace under Commands. It will then ask us to name our workspace and choose where to store it. After doing these, we can click on Create Workspace to create our workspace. The next step in ADS is to create our schematic window. We do this by clicking on the new schematic icon on the toolbar. It will then ask us to name our cell. After doing this, we can click on Create Schematic. A schematic window will appear. This is where we will be building all of our circuits. We can now start building our circuit. Before we build our circuit, we have to find out where our components are. There are two ways of finding components. First, we can search using the search bar by typing in the name of the component. And the second way is to search using the component palettes drop-down menu. The circuit that we will be building is a one-port network, comprising of an ideal transmission line, a resistor, and a capacitor. I will start by clicking on my resistor in the Basic Components palette and dropping it anywhere on the schematic window. You will notice that there is an outline of a resistor floating around as I move my mouse. We can get rid of this by clicking on the Escape key on the keyboard. I will then place my capacitor next to my resistor. I will then search for my ideal transmission line in the Components palette under T-Lines Ideal. Then I will place my transmission line on the schematic next to my resistor. In ADS, in order to mimic the ports of a network, we need components known as terminals. Since this is a one-port network, we will need only one terminal. A grounded terminal can be found under the Basic Components palette. We will place that where the source of the circuit would be. And then we will add a ground, which can be found in the toolbar, to the other end of the circuit. Finally, we will connect all components together using wires. To do this, we click on the Insert Wire icon in the toolbar and connect the red nodes together. Next, I will show you a few things you can do with your circuit. First, you can change the values of the parameters of your components. You can do this by double-clicking on your component and either changing the value or you can change the unit. There are also other parameters that can be changed. However, if you don't know what the abbreviations mean, you could click on them and there will be a description provided below the parameter box. Second, you can short components by selecting them and clicking on the Deactivate and Short or Activate Components icon in the toolbar. To reactivate the component, you just repeat the same process. Lastly, in the same way you short components, you can deactivate them. For example, if you decide to use another circuit you built below your original circuit, you can highlight the original circuit and click on the Deactivate or Activate Components icon in the toolbar. To reactivate your circuit, you just repeat the same process. We will now get to simulating our circuit. To simulate S parameters, we need an S parameter simulation object, which can be found at the bottom right corner of the Basic Components palette. We can drop that anywhere on the schematic window. It will allow us to select our start and stop frequencies, as well as our step size and number of points. If we decide to simulate at a single frequency, we go to where it says Sweep Type and choose Single Point from the drop-down menu, and then choose what frequency we would like to simulate at. For this demonstration, we will be simulating from 0.1 GHz to 1 GHz, and we will use 1,000 points to make sure our curve is smooth, and then click OK. We will then simulate by clicking on the gear icon in the toolbar. It will open a simulation window and then a graphic window where we will be plotting our S parameters. On the display window, we can plot our S parameters on several charts, like a rectangular plot, a Smith chart, and a polar chart. Today, we will be using only a Smith chart and a rectangular plot. I will click on the Smith chart and drop it anywhere on the window. We will be plotting the reflection coefficient, so I will select S11 and then click Add. S11 will then be plotted on the Smith chart. We can also do this with a rectangular plot by clicking on the rectangular plot and dropping it in the window. We select S11, click Add, and choose the format we would like it to be in, which is decibels. And then click OK. And then OK again. And then it will plot S11 on our rectangular charts. If we would like to know what our reflection coefficient is at a single point on the curve, we can click on the Insert a New Marker icon in the toolbar and select the curve we want. We can also move the marker with the mouse to the point we would like it to be, and we can also move it with the left and right arrows on our keyboard. We will then place a marker on the Smith chart as well. We can see that S11 has two values. The one on the left of the slash is the magnitude, and the one to the right is its angle. You will also notice that the impedance is the characteristic impedance times a complex number. We can make this simpler by double-clicking on the box, going to Format, and changing Z0 from normalized to 50. This will multiply the complex number by 50 and give us the actual impedance. The last thing I will show you is how to compare two charts when you change the value of your components. To do this, click on History in the menu bar and then click On. Make sure that there is a green H on your chart. You will then go back to the schematic we created earlier and change for example, our resistor, from a 50 ohm resistor to a 100 ohm resistor. And then we will simulate. Our new curve will be plotted in blue right next to our old curve. I hope this video was helpful, and I wish you good luck in your class. Thanks, and giggle.